This video is going to take a look at the rest of the types of triangle problems that you might expect to see. If you need to at any time pause, rewind, to get everything copied down, you can, or just to even take a break, because this one's going to be a little longer since there are 4 problems left here. Okay, so we're starting with cosecant is 3. Important thing for that probably is to figure out what sine is. So we have 3 for cosecant, which means and that's really 3 over 1, which means sine would be 1/3. It's also giving us this information, pi over 2, less than theta, less than pi, so that is putting us in the second quadrant. So we're going to draw our triangle here, we'll put in the opposite and the hypotenuse, and then we're going to calculate the missing side. So we would do x squared plus 1 squared equals 3 squared. Now it's going to be important for simplifying in this. We're going to get the square root of 8, which would simplify into 2 square root of 2. So we're going to use that value here, and it is negative because we are going to the left. So for cosine, we're going to have negative 2 root 2 over 3. Let's do the easy ones first, where we don't have to rationalize. For cotangent, since we have x over y, that will be negative 2 root 2. And then if we flip over, let's do the cosine first, we flip that over and rationalize. So we'll end up getting negative 3 root 2 over 4. And then for tangent, same thing. We are going to take 1 over negative 2 root 2 and rationalize that. Again, make sure with the negatives, you look to see that 4 of your functions are negative and 2 are positive. If you're in a quadrant other than quadrant 1, that's going to be something to look for. All right, our next example, we're actually going to be given 2 functions. You technically wouldn't need to draw a triangle for it, but we're going to. So you're actually given sine and cosine, and in order to do this, you could use those 2 values to find your tangent value, and then you can flip all of those over to find the other one. So we have negative 2 root 10 over 7. So actually, I'm going to find all the values first, and then go back and show you how you could use the triangle. Since tangent is sine over cosine, tangent is just going to be negative 2 root 10 over 3. Really, you can flip everything over at this point. So if you're given 2 functions, although you can graph it in the correct quadrant, you don't really need to. Unfortunately, we do have some fun rationalizing going on this one again. So we're going to get negative 7 root 10 over 20 for cosecant, and then we're going to get negative 3 root 10 over 20 for cotangent. So really, you don't need to set the triangle up. If you wanted to set the triangle up, it would end up being in quadrant 4, because that's where sine is negative and cosine is positive. It's important to know where the functions are, positive, negative. And you can do negative 2 root 10 over 7. And the nice thing is nothing has been simplified, so you can actually fit all your sides on there with the correct negative signs. You really don't need the triangle for this one, but you can set it up to help. This is another set of 2 trig function situations which we can fill in. This one, I would say the triangle setup would be important, because unfortunately you're seeing a radical here, which possibly means that tangent has been rationalized, and that's going to mess you up. So first thing you want to do we'll use the sine value. We're going to look for the quadrant. We want to figure out a quadrant where both are negative. Same quadrant actually as before. We're going to be working in quadrant 4. We have opposite over hypotenuse, so we have 1 and 3, and the negative sign will be on the 1. Missing side, x squared plus 1 squared equals 3 squared. So our missing side, again, is our 2 root 2. That's going to be our x value here. So even though we are given two functions on this, and we could work with that, if you're given sine and cosine, I would say probably no triangle is necessary. But if you're given sine and tangent or cosine and tangent, and the values don't really match up in terms of your opposite, adjacent, hypotenuse, then I would set the triangle up and solve from there. So what you're going to see is for cosine, it's actually going to be 2 root 2 over 3. And now you can tell if you were to divide, you would have a radical on the denominator, which would have needed some rationalizing. Cosecant will just be negative 3. Cotangent, we can actually do just negative 2 root 2, now looking at the triangle, rather than flipping over tangent and rationalizing. So the only one that needs rationalizing is secant. We'll flip over cosine, multiply by root 2 over 2, and we'll get 3 root 2 over 4 for that one. So I would star this one. I feel like this still needs the triangle, unlike the last example. Okay, and our final example is kind of different, but it's not giving any of the trig functions. It is giving you a point value, and that's kind of similar to what we looked at when we first started doing the exact values and setting up these triangles. So let's take a look at that one. Okay, so here you're given the point negative 6, negative 8. So we're going to graph that in quadrant 3, because that is where that point will fall. And really, our x value is negative 6, our y value is negative 8. So we've already been looking at these kind of as points. That's giving you your opposite and your adjacent. We just need to figure out the hypotenuse. The nice thing about this one, it's a 3, 4, 5, just multiplied by 2. So that our hypotenuse will be 10. You can also simplify this down, if you'd rather, into a 3, 4, 5. Since you're going to be simplifying later anyway. And we're going to get negative 4 over 5 for sine, negative 3 over 5 for cosine, 4 over 3 for tangent. I'm just going to make a quick note that this is the slope. That's something you're going to be seeing a lot more in pre-calc and then ultimately in calculus, that your tangent line is your slope of your line at that point. So we have slope there. We'll flip them all over, negative 5 over 4, negative 5 over 3, and 3 over 4. So you can use the 6, 8, and the 10, but if you actually simplify the triangle down, if possible, you'll have all the values simplified already, and you're good to go. That concludes the triangle examples. You'll be doing some practice of this after from the textbook.